Hello, 7th graders. By now you should have your day 3 notes out on your table. If you forgot to take your notes or don't have them with you for some reason, you still need a piece of paper out because we'll be adding some things to your notes as we go. So day 3 was all about graphing proportions. The essential question says, how do you determine if a graph is proportional? So in your notes, we're going to pause the slideshow right here. In your notes, somewhere towards the end where you have some space, I would like you to write down the word key ideas. And we're going to be adding some things to your notes as we go. There are 3 key ideas to tell if something is proportional. So the first thing is if 0, 0 makes sense. So write that down, and then we will go back to the slideshow and talk about it. So does 0, 0 make sense? So let's go back to the slideshow and do some examples so that you can see what that means. So this says a key to knowing if a situation is proportional is identifying that they are 0 together, meaning if one is 0, the other makes sense as 0 as well. So here's an example. If you earn $10 in 2 hours, how much will you earn in 5 hours? Well, in order to test for 0, 0, you have to think, if you earn $0 for 0 hours, does that make sense? For example, if you work for 0 hours, are you earning any money? No, you're not. So that means 0, 0 does make sense, and it means this situation is proportional. Here's another example. If Julie can eat 5 cookies in 2 minutes, how many can she eat in 8 minutes? Well, think of 0, 0 again. You're comparing cookies to minutes. So does it make sense that Julie would eat 0 cookies in 0 minutes? Yes, it does. That means this situation is also proportional. Okay, if 0, 0 does not make sense, then the problem is non-proportional or not proportional. So for example, this was from a few years ago, but when I was 29, I had a brother that was 24. How old will Tyler be when I'm 64? Okay, so you're going to see this on your homework tonight. You're not answering this question. You're just saying, is this situation proportional or not? So if I'm 29 and my brother is 24, were we 0, 0 at the same time? Meaning, were we born at the same time? No, because I'm 5 years older than him. I've always been 5 years older than him, and I always will be. Okay, so since we were not born at the same time, 0, 0 does not make sense. That means this is not proportional. All right, you can also see 0, 0 when looking at graphs. So on this graph, this is just a quadrant 1 graph. So 0, 0 is right here in the corner. So this line goes through 0, 0, so that means it's proportional. If the line does not go through 0, 0, like this one, it goes through 0, 1, that means it's non-proportional. Remember, 0, 0 is the origin, so if you see a 4-quadrant graph, 0, 0 would be in the center. These are just 1-quadrant graphs, so that's why 0, 0 is in the corner. All right, the second key idea, so go back to the end of your notes here. The second key idea, is that the graph has to make a straight line. Okay, so write down that is the second key idea. So let's go back to the slideshow and talk about that. So proportional graphs also have to make a straight line. So this graph not only goes through 0, 0, but it also makes a straight line. So if you have a graph that does not make a straight line, that's the second indicator as to whether it is proportional or not. If it does not make a straight line, it is not proportional. If the graph makes a straight line, the third thing that you need to test is whether it has a constant rate of change. So go back to your key ideas. The third thing is constant rate of change. Oops, sorry, it helps if I spell constant right. constant rate of change. So what that means, and you should add this to your notes, is that every y divided by x, y, see if I can get the division symbol here, y divided by x equals the same number. Okay, and we'll do an example of this so you know what I'm talking about, but just take a moment and add that to your key ideas. The constant rate of change means that every y divided by x gives you the same number. Okay, so let's go back to the slideshow. So besides this graph making a straight line, if we do y divided by x, remember the y is always on the right and the x is on the left. It goes x, y, like in alphabetical order for the table. X on the left, y on the right. Okay, so 0, 0 is 0 divided by 0 is always 0, so we don't count that row, we count the next row. Now in this case I happen to do it backwards, 3 divided by 2, but it shouldn't make a difference. Okay, it should give you the same thing every time anyway. So 3 divided by 2 is 1.5, 6 divided by 4 is 1.5. If you do it the other way, 2 divided by 3 is 0.6 repeating. 4 divided by 6 is also 0.6 repeating. So if you get the same number in red right here, then it has a constant rate of change, which means it's proportional. Okay, so this graph not only goes through 0, 0 and makes a straight line, but it has the constant rate of change. You have to have those three things in order to be proportional. Okay, so to recap what we've talked about so far. To be proportional, 0, 0 has to make sense, the graph makes a straight line, and it has to have a constant rate of change. So every y divided by x should give you the same number. So let's do a few more examples. So here's an example of rate of change. So the x is always on the left and the y is always on the right. So in this case, we're going to do the water divided by the time that it takes to fill the pool. So 80 divided by 2 is 10, or 80 divided by 10 is 8. The next one would be 60 divided by 20, which is 3. Already you can see they do not equal the same number. So this would not be a constant rate of change. You could stop there, but just to verify, 40 divided by 30 is 1.3 repeating, and 20 divided by 40, I accidentally wrote this one backwards, is 0.5. Okay, so you're looking at these last numbers here. This does not give you the same number every time, which means this situation is not proportional. Next one, burgers and people. So if 5 people ate 10 burgers, to find the constant rate of change, you do 10 divided by 5, which is 2. For the next row, you do 14 divided by 7, which is 2, 20 divided by 10, which is 2, and 30 divided by 15, which is also 2. If you get 2 the whole time, the same answer for every row, that means this situation is proportional. All right, so we're going to run the test. We're going to look at the 3 key ideas for each of these situations and see what we can figure out. Remember what your key ideas are. 0, 0, straight line, constant rate of change. That needs to become your mantra today. That means you're going to repeat it for every single problem that you do. 0, 0, straight line, constant rate of change. So let's go back to the slideshow. So this graph goes through 0, 0, and it makes a straight line. And if we did the constant rate of change, for this point, we would do 10 divided by 2, which is 5. For this point, we would do 20 divided by 4, which is also 5. For this point, we would do 30 divided by 6, which is also 5. So those fit every qualification, the 3 key ideas. That means it's proportional. This graph goes through 0, 0, but it does not make a straight line. So you do not even need to test for the constant rate of change because it's not a straight line. So that's not proportional. This graph starts at 0, 3, I believe, not 0, 0. So right off the bat, it does not hit the first key idea, so it is not proportional. All right, in your homework today, you're going to be asked to actually graph some proportions. So you need to make a table first. Okay, so here's an example of that. If you earn $10 in 2 hours, how much will you earn in 5 hours? So we're going to make a table. If you don't work at all, you make no money, right? So 0, 0 would be the beginning. If you work for 2 hours, you get $10. That's what it says in the problem. And then we just go up from there. So 2 more hours would be $10 more. 2 more hours would be $10 more. Then you can make the graph and you can see it's 0, 0. So and it's a straight line and it's a constant rate of change. All of these have a constant rate of change of $5 per hour. So that means this is a proportional relationship. Here's another one. If you drive 150 miles in 3 hours, how far can you drive in 7 hours? So make a table. If you don't drive at all, you've obviously spent no time and you've driven 0 miles. So for every 3 hours, you drive 150. So we just keep adding 3, add 150, add 3, add 150. When you graph it, you can see it goes through 0, 0. It makes a straight line, and the constant rate of change is 50 miles per hour if you divide each of these. So this is a proportional relationship. Here's another example. Erica was working on her essay for language arts. She had 1 page written already. Then she wrote 3 pages per hour. So at 0 hours, she had started with 1 page. Maybe she did that during class. So then the first hour, she adds 3. Second hour, she adds 3. The third hour, she adds 3. Already, you can see when you graph this, it does not start at 0, 0. It starts at 0, 1. So this would be not proportional. All right, so just to recap, please remember the 3 key ideas. Okay, like I said, this is going to be your mantra. Think of this, have this open while you're working on your homework today. Does 0, 0 make sense? Does it make a straight line if you graph it? And is there a constant rate of change? Remember, when you make tables, the x always goes on the left side and the y always goes on the right. So if you need to put an example here for yourself, that might help. So the x always goes on the left, x would be here, y would be here. Okay, so you're always doing y divided by x, whatever the second number is, divided by the first number. And that's all I have for you today, and now the teacher will be passing out the additional examples, and she will take it from here. Thank you very much.